The invisible bullet. Why we aren't ready for the next asteroid. In February 2013, an object heavier than the Eiffel Tower slammed into the atmosphere over Russia. It exploded 30 kilometers above the ground with a flash brighter than the sun. But the most terrifying part wasn't the explosion. It was the silence. For a full 90 seconds after the blast, there was no sound. People ran to their windows to look at the smoke trail, thinking the show was over. That is when the shockwave hit. It blew out windows across the city, sending glass flying into the faces of thousands of onlookers. Here is the part that should keep you up at night. We didn't know it was coming. The blind spot, that very same day, scientists were congratulating themselves for predicting a completely different asteroid flyby. We were watching the front door while a city killer sneaked in through the back window. This isn't an isolated incident. Since 1988, over 1,200 asteroids larger than a meter have collided with Earth. Of those, we detected exactly 5 before impact. And never with more than a day's warning. With all our advanced telescopes and space technology, we are flying blind through a cosmic shooting gallery. The question isn't if we will be hit again, it is when. And whether we can do a single thing to stop it. The Rubble Piles. To understand the threat, you have to understand the bullet. Asteroids aren't just solid rocks floating in space. They are the violent leftovers of our solar system's birth. Some are solid metal cores of dead planets. The oldest objects you will ever touch. But many others are rubble piles. Loose collections of gravel and dust held together by nothing more than weak gravity. Hitting one of these isn't like shooting a rock. It's like shooting a floating sandbag. And that makes stopping them incredibly difficult. The limitation of sight finding them is harder than you think. Most asteroids are dark, reflecting only about 15% of the light that hits them. Imagine trying to spot a lump of charcoal against a black curtain from 1,000 miles away. We usually only see them when they are fully lit by the sun. That means if an asteroid is coming at us from the direction of the sun, we are effectively blind. That is exactly what happened in Russia. The impact. What happens when we miss one? In Arizona, there is a crater named after Daniel Barringer, a man who spent 27 years drilling into the ground looking for the giant metal meteor that made it. He found nothing. He didn't realize that at orbital speeds, a rock doesn't just hit the ground, it vaporizes. The kinetic energy is so immense that the solid rock instantly turns into a superheated gas, exploding with the force of a nuclear bomb. The asteroid that killed the dinosaurs wasn't just a heavy rock. It turned the entire atmosphere into a toaster oven. The sky didn't just go dark, it glowed red hot. Anything not underground or underwater was cooked alive within hours. The probability trap. The good news is that dinosaur-killing asteroids are rare. One every 100 million years or so. We have mapped almost all of them, and we are safe for now. But the real danger isn't the planet killer. It's the city killer. For every giant asteroid, there are thousands of smaller ones capable of wiping out a country like Germany or France. We have found most of the big ones, but the medium-sized ones, the ones that could obliterate a city like New York or London, we are missing a lot of them. The deflection myth. If we saw one coming tomorrow, could we stop it? Hollywood says we just launch a nuke. In reality, that is a terrible idea. If you blow up a rubble pile asteroid, the gravity just pulls the pieces back together. Or worse, you turn one bullet into a shotgun blast. What about strapping rockets to it? We don't have rockets powerful enough. Lasers? We can't build one big enough. Wrapping it in reflective foil, we can't launch enough foil. The terrifying truth, concluded by committees of top scientists, is that right now, we have zero ability to deflect a large asteroid. The final option, we even looked at evacuation. But imagine trying to evacuate a city like Los Angeles with a week's notice. The freeways would gridlock instantly. So where does that leave us? We can't stop them yet. We can't evacuate effectively. Our only move right now is to find them early. We need eyes in the sky. Space telescopes dedicated to hunting these threats down years before they arrive. Because once we find the bullet with our name on it, maybe then we will find the motivation to build the shield. Until then, we are just watching the sky and hoping for silence. If you found this informative, click like and subscribe. We will be covering many more topics on space and computer technology.